Hey everyone, in this video I'm going to show you how to interpret the slope and the y-intercept for the line of best fit of a scatter plot. Okay, in the previous videos I showed you how to create the scatter plot. I showed you how to add the line of fit and get the equation for the line of fit and the r squared value to show on the graph. And now we're going to take that equation and we're going to talk about what it means. In other words, we're going to interpret it. Remember that the equation of a line is usually in the form y equals mx plus b, and that's exactly what we have here. So if I zoom in a bit, you can see that I have y equals 1.34x plus negative 35.9. So off to the side over here, I can put in that equation or kind of extract it out and get y equals 1.34x minus 35.9. All right, that's going to be my equation for the line of best fit. So the m, which is the slope, that's the number right here that's attached to x. Okay, remember that from previous courses. M is the slope, and in this situation, it is 1.34. The b, which is the y-intercept, that is the number that doesn't have an x attached to it. That's over here. And so the b, again, that's the y-intercept, in this situation is negative 35.9. So finding it is great, but most of the time in these real life situations, we want to interpret. So what does that slope mean in the context of this problem? I added this sentence frame down here. This is basically all you need to know. This is exactly the sentence frame that you can use to interpret the slope of a line of best fit. And so the slope, remember, it's the change in y divided by the change in x. That's the kind of the math way to think about it. So in real life, it's going to be the change in y, in this problem that would be quantity sold, divided by the change in x, which in this problem is the average temperature. In other words, it's for every 1 unit change in x, anytime x goes up by 1, so in this case, anytime we increase the temperature by 1 degree Fahrenheit, the y, which in this case is quantity sold, so the quantity sold will go up or down. This is a positive number, so it's going to go up. If the slope was negative, you would say it goes down. You can choose one of those two. How much does it go down by? Well, whatever that number is. So this number is the amount that y changes when the x changes by 1. Okay, let me type that out so you can see that a little better for this problem. For every 1 unit change in, what's x? Average temperature. Average temperature. The y, what's y in this problem? Quantity sold. The quantity sold will go, it's a positive number, so it will go up by whatever the slope is, 1.34. All right, so that is how you interpret the slope here. For every 1 degree increase in temperature, we would expect to sell an additional 1.34 bottles of lemonade, because this is the me and the bees lemonade data. All right, what does the y-intercept tell us? Well, this is just for the slope, so I can kind of get rid of that. The y-intercept, remember from your Math 1 or your Algebra 1 class, the y-intercept is the y value when x is 0. y value when x is 0. So quantity sold is your y, your x is your average temperature. So in words, this means that you would expect to sell negative 35.9 items when the average temperature is 0. Again, it's the expected y, whatever y is, in this case quantity sold, when the x, in this case temperature, equals 0. Now hopefully you're hearing that and thinking that that doesn't make a lot of sense. You can't sell a negative number of items, first of all, and also you're probably not having a lemonade stand when the average temperature is 0, right? If it's 0 degrees outside, it's unlikely you're going to have a lemonade stand. That's okay. These questions, unless they ask you, does this make sense? These questions aren't asking about, are they sensible? They're just asking you, if it just says to interpret, it's just saying, tell me what it means. Again, oftentimes it'll follow up with a question like, does this make sense? But not always. I hope this helps, and I hope this gives you some insight on how to interpret the line of best fit, the slope and the y-intercept of the line of best fit.